Okay, in this presentation what we are going to do is calculate the Spearman rank correlation coefficient. So what I got here is two variables, dBp and SBP. Now, just for the sake of brevity, I'm going to keep this really short, but actually these are related to blood pressure measurements, and this is the type of thing that you might see in medical statistics. So dBp is diastolic blood pressure and SBP is systolic blood pressure. Okay, so what I'm going to do actually is just have a quick look at the data here. So I'm just going to sort of scroll up there. So I just unpaused it there, or unfroze it there, just to make it a little bit easier to read. So what we have here is 10 observations, 10 pairs of observations, just make it a little bit, bring it into focus there. So we have 10 cases, that's it, there's only 10, okay. And we've got a pair of measurements for both variables, dBp and SBP, okay. Now just for the sake of simplicity, what I've done here is I've presented the dBp in ascending order, just to make things a little bit easier. If you want to do that, it actually just makes things a little bit easier. Just actually sort of, you might reorder one, if possible, just to make it a little bit easier to pick out the rankings. Okay, because we're going to be working on rankings, because after all, this is the rank correlation coefficient. Okay, the Spearman rank correlation coefficient. Okay, so what I'm going to do actually is just set up a new table here. Okay, and I'm just going to present it here like this. Okay, and what I'm going to do here is I'm going to sort of just calculate the rankings. Okay, so from bottom to top, what I'm going to, so lowest minimum to maximum, what I'm going to do is assign the ranking, with 1 being the lowest, the minimum. So 55 here is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So just sorry, 10 is just gone out of shot there, but that's all I had to do there. Okay. Now, unfortunately, life is not so easy, and we have to do the same thing now for the systolic blood pressure. Just get that out of the way. Okay. So this is just to sort of have to sort of glance through it here, and very gingerly just check. First off, actually, in just this for this particular example, there are no ties. Okay, so the lowest here is 105. Okay, so the next lowest after that is 115. After that is 120. Okay, 3. Okay, what's next? 125 is 4. 130 is 5. Okay. This 135 is ranking 6, 7, and it gets easier now, 8, 9, and 10. Okay, sorry, just put that up at the bottom again. I just spotted there 8, 9, and 10. Okay, so I'll just let you give you again. There's no rank ties here, so that actually helps us a lot. Okay. Now, I'll do another video where you have to look at what to do with when there's in the case of a tie. Okay, so what I'm going to do now is actually calculate the difference between rankings. Okay, and so the difference between rankings. Now, I'm going to work on the basis. It doesn't really matter which direction you work on, as long as you're consistent. So I'm going to work left minus right. Okay, the ranking on the left minus the ranking on the right. So this is 1 minus 4, so that's 1, 4, okay, so this is minus 3, okay, 2, 2, difference there is 0, 3, 3, difference is 0, 4, 6 is minus 2, 5 and 1, that is 4, 6 and 7, minus 1, push that up a little bit. 7 and 5, that's plus 2. 8 and 10, that's minus 2. 9 and 9, that's 0. 10 and 8, that is 2. Okay, so this last column here is the key part there. Okay, so it's the difference in rankings is what I am particularly interested in. Okay, So that's the first part, and that's actually the key part of the calculation. Is the key element is actually using these here. Okay. Now, just for the sake of space, I did not do this, but what you might do actually is you actually might continue on your table to the right hand side here. I'll just show you what I mean here. It's just I deliberately didn't do it just to make for the sake of space, but just actually. That's only for the purposes of making the video. Okay? So what I'm going to do now is bring in the equation. So that's the Spearman rank equation. RS equals 1 minus 6 times the summation of these differences squared. Okay? So we squared the differences and sum all of them up. Over n times n squared minus 1. Now this is a very straightforward calculation here. The n squared minus 1. So n is 10 in this case. N squared equals 100. 10 squared. N squared minus 1 is 100 minus 1, which is 99. And 10 times 99 is 990. Okay, so that's just that denominator part just taken care of there. Okay, so essentially all we have to do here is sum up all of the case-wise differences. Now, again, this is just a continuation of the table. You can really just regard this as a continuation of the table on the last page. But again, and you can actually, when you're doing this yourself, just add it on as an extra column. Okay. So anyway, minus 3 squared is 9. Just to actually remark, as long as you're consistent with the directions. Left minus right, or right minus left, or x minus y, or y minus x. It doesn't matter because they get squared after the fact. 0, 0, 4, 16, 1, 4, 4, 0, 4. Okay? Now, what I'm going to do is sum all of those up. Just for the sake of clarity, or the sake of brevity, I'm just going to ignore the zeros when I do this bit. So I just dropped out the zeros there just to make it a little bit easier to read. So it's 9 plus 0 plus 0 plus 4 plus 16 plus 1 plus 4 plus 4 plus 0 plus 4. There it is there. I just dropped out the zeros just to make it a little less cluttered. When we add them up, we get 42. Okay. And the formula requires us to find 6 times that value, which is 252. Okay, so we're nearly there. Let's just bring up the next slide, the next page here. So that's it there. That's the formula again. We've calculated all the relevant components. So it is. We just found there that it was 252 divided by 990. When you work that out, you should get 0.7455. And that's the answer. That is the Spearman correlation coefficient.